Morning students, Sairam, this is Megha Miss here, and today we are going to continue with our lesson number 3, that is current electricity. Now we are in our session 4 students. Now in the previous session students, what we studied, we'll just have a recap. Okay, now you studied about the resistance and resistivity of a conductor. Yes students, you studied what is resistance, that we also saw in the Ohm's law, that was V is equal to IR and R is the resistance of the conductor, right? We have seen that there is a hindrance when there is a flow of the current through the conductor, and that hindrance we called it as the resistance of that conductor. Okay, we also saw that different conductors have got different resistivity. Yes, then we studied what is the electric circuit. Yes students, what is the electric circuit? Electric circuit is containing different components. Yes, we studied that in order to have a complete electric circuit, we need different things, right? You need connecting wires, you need a cell, yes, you need a key. Yes, you can attach many cells and make it into a battery, and then you can attach a battery also. Then you can have, you need a resistor, you need, okay. Then you need a voltmeter to measure the voltage. Yes, then you need an ammeter to measure the current flowing. Yes, so many components are there which will together make your electric circuit. Okay student, then we studied what are conductors and insulators. Yes, conductors, in short we can say that they are the good conductors, yes, of electricity, and especially we are talking in terms of metals, right? And insulators we saw like the glass, we saw rubber. These are the substances which are not capable of conducting the electricity, so we call them as the insulators. And yes, we also use this insulators, yes or no, in electric connections you have this insulators also. Yes, so I hope whatever part we studied in the last presentation you have understood that. Okay students, now we will continue with the next topic. So today the topic which we are going to start with, that is the system of resistors and effective resistance. Now what is this? Now see here, a resistor is a two-ended component. Yes, in a resistor you have two ends. One is your positive end and one is your negative end. So it is a two-ended component having a given amount of resistance between its two ends and some specific value of resistance it has, okay, between these two ends. In several electrical devices, a number of resistors are connected together. Okay, sometimes it happens only one couldn't help to run that device. So what is happening? We are attaching many resistors together. Okay. Now in several electrical devices, a number of resistors are connected together in different ways. Okay. Ohm's law is applicable to all such connected resistors. Okay students, so which law is applicable there? The Ohm's law is applicable to all such connected resistors. I can connect the resistors. Okay, now we'll see. Okay, so I am just showing you this is the different names of the components which we have in the circuit, as well as the diagram and the symbol which we draw when we draw it in the circuit diagram. They have been given the table, I told you, but that table has been cancelled for you this year from your syllabus. But then also students, I would suggest that please see that table. Okay, from that, as this are the four main which are we are going to use it, and I am talking about again and again, I thought I'll show you to it. Okay, you can see here the resistance which we are talking so many presentations. See here, it will look like this. Okay, and while drawing you are going to draw it in the circuit diagram. When you draw it, it should be in this way. Okay, we don't draw this. Okay, we draw this one. Okay students, then variable resistance means I want to change the value of the resistance. Okay, I need a variations, so it is variable. Okay, so like this is that instrument which I am going to attach in my circuit. Okay, and we draw it in this way. Okay, this is called, and in circuit surely you will draw it in this way. We don't draw this figure. Okay, then next I told you ammeter, which we are using for what students? Yes, for measuring the current. Yes, see, it will look like this. Okay, the instrument looks like this, and when you draw it in the figure, you will draw it in this way. Okay student, same way, see the voltmeter also how it looks. See, the values are also there. I told you the values are calibrated on that device. Okay, and when you draw it, you will draw how in the circuit it is also shown. Okay, you have for ammeter also you have two wires, positive, negative. Voltmeter also you have two values, positive and negative. Okay student, so in fact this table is was important for you, it would have helped you out, but just go through this table. This were the four main which you should know, key and cell and all. Now you know how it is. Okay, so I didn't include that, but these are the four main things which we are going to use it now when we are going to do the circuit. So I thought I should tell you this, but please again you go through the table, see the symbols. Okay, what the symbols what we draw means, I am talking about this or this and this. I am talking about this or not this instrument. This instruments we don't draw in the circuit. For just to understand, I have made it. Okay, is it clear students? Okay, so we'll move to the next part. Now see here, resistors in series. Now what is this students? Resistors in series we will see. You can see that the ends of the three resistors are connected so that they follow one after the other in a single line. So we'll just see it here students. We are talking about the resistors. Now only we saw how we draw the resistor, right? See, this is my resistor 1. Okay, this is my resistor 2 and this is my resistor 3, right? So three resistors, how they are connected? They are connected one after the other in a single line. Can you see they are in a single line? Yes. These resistors are said to be connected in series. Okay students, what is important here? Series. When you connect the resistors in this way, you have seen the diagram also how the resistor looks. Okay, when such resistors I connected in this way, different three resistors I connected this way through the help of the conducting wires, we call it they are in the series. Okay students, I hope till here it is clear. Okay, we'll proceed. See here. Now what is next? In such an arrangement, the same current flows through each resistor. What will happen? The current which is flowing. Okay. Now if see here, the cell is there, a key is there, okay, ammeter is there, and voltmeter is also there. Okay, so whatever the current will be flowing through this conducting wires, whatever it is flowing, it is going to be same for each resistor. The current is going to be same. Okay, the value of current is I. How you are going to show the value of current? As I. Okay, we take it as I. And the potential difference between C and D means this point to this point, the potential difference we are going to take it as V. Okay students, now we will just proceed. I hope till here it is clear. Okay, now the three resistors R1, R2 and R3 are connected in series in the circuit. Yes, now only we saw. If V1, V2, V3 are the potential differences of every resistor R1, R2, R3 respectively. Okay, means what? If the how much voltage students from here I'll take it as V1. Okay, for R2 I'll take as V2 and for R3 as V3. Okay, then what we can have? We can have total voltage, that is V. Okay, how I'll write it students? You can see V1 plus V2 plus V3. Okay, if RS, okay, that is S for series we write, is the effective resistance, means effective is totally I am taking in the circuit between C and D, then according to Ohm's law, you know the Ohm's law, what it is? V is equal to IR. Okay, now instead of writing only R, I will write it as RS because we are calculating for this series circuit. Okay, now what will happen for the, now you have I, see here what will happen now, you have V1, V2, V3. So we will apply this Ohm's law to all of them. So what it will happen, see student, V1 is equal to I R1. Okay, V2 is equal to I R2. I is going to remain constant. We have seen current will be same through all. So every time I will not write it I1, I2 and I3. I will write it as I only. Okay, and V3 is equal to I R3. Okay students, did you understand this? I have applied the Ohm's law to all these three resistors. So it became V1 is equal to I R1, V2 is equal to IR2 and V3 is equal to IR3. Okay, I is, as the current flowing is constant. Okay, constant value of the current. I am not writing it as I1, I2 and I3. Okay, so substituting all this in equation 1. So here in this equation 1, all this value, V value you have got IRS. Okay, so that I'll put it here. V1 value you got now IR1, V2 value you have got IR2, V3 value you have got IR3. So this all values I'll substitute. Okay, so what we are getting, we'll just see, students. So students, we get it. IRS is equal to, as I told you now only, IR1 plus IR2 plus IR3. Okay, now here students, you know what you know. I is current is a constant value, it is same. So what can I remove? I can take I common from here. Yes, from here can I take, for all this I can take I common. Then this I, okay, this I and this I can get cancelled out. Okay, then what is remaining? RS is equal to R1 plus R2 plus R3. Okay student, here I common means I am taking out, and in bracket here I'll show you, just a moment. Yes, see here, I can take I common, in bracket I can write R1 plus R2 plus R3. Okay, my bracket closed. Okay, so this I, this is equal to, right? So this I and my this side I can get cancelled out. So what is remaining? RS is remaining from here, and this R1 plus R2 plus R3. Is it written here? Yes, I hope now it is clear to you. So if n resistors are connected, n means n number of, more and more number of resistors are connected in series, then RS, that is the resistance in series, will be equal to the resistance of the addition of the resistance of the individual resistor. So R1 plus R2 plus R3 plus so on, so on, so on, so on, and it will be Rn. N means n number of resistors I can put it up. Okay students, did you understand till here? Okay, so we'll move to the next part. So if resistors are connected in series, first point what you will remember, the same current flows through each resistor. Yes, we have seen I remains constant value. Okay, the effective resistance, that is RS, of the resistors is equal to the sum of their individual resistances. Yes, RS, which is the effective resistance, it was equal to the sum of, means R1 plus R2 plus R3, we went so on na. So it is the equal to the sum of the individual resistances. Yes, the potential difference between the two extremes of the arrangement is equal to the sum of the potential difference across individual resistors. Yes, we saw V, right, is equal to V1 plus V2 plus V3. Yes, that means the V value, what is the total potential? Yes, that is equal to what? Sum of the potential differences across individual resistors. Okay, individually we took now V1 for R1, V2 for R2 and V3 for R3, and then we added up. So first we took it individually, V1, for R2 we took it as V2, and then we added it up, right? So again I'll read the potential difference between the two extremes of the arrangement. Yes, point C and D were the two extreme points, and that voltage, that is V, is equal to the sum of the potential differences across individual resistors. Okay, then the effective resistance is larger than each of the individual resistances, means the RS value will be always larger than R1 value, okay, R2 value or R3 value. Or okay, did you understand this? Then this arrangement is used to increase the resistance in a circuit. When we have this, okay, when we connect the resistors in series, when we want to increase the resistance, that is the hindrance of the flow of the current in the circuit. Okay students, I hope all this 5 points are the characteristics we can say about the resistors which are connected in series. Okay students, important one, you have to study this properly. Okay, this also again have a connection with your 10th standard chapters, so please remember this, study this properly. Okay students, so I hope what we studied today, only one topic I took, okay, because it is very important, study them properly. The equation you have to solve and see, and you have to bring it up to Rs is equal to R1 plus R2 plus R3, so on, and Rn. Okay, Rn, there small n means number of resistors you can attach, not only 3, you can have 4, you can have 5, okay, depends which device you need it. Okay students, so I hope what we studied today, go through it. Circuit diagram is also important, draw it in your book and practice. And I want you to write this resistors which are connected in series in your notebook. Okay, from this presentation only you can write it. Okay, this was the first part which we studied, which was connected with the Ohm's law, that were the resistors which are connected in series. In the next presentation we will study how the resistors are connected in parallel and what the equations we are getting. Okay students, so I hope today's part is clear to you. Go through the video properly. Okay students, so I'll stop today for here. Next presentation will continue the parallel. Okay, for the parallel resistors which are connected in the parallel we will see. Okay students, thank you, take care, Saira.